In some next problems, we're going to look at the graphs of the secant and the cosecant. So we'll start out here by just looking at the graph of y equals the secant of x. And remember, the secant is 1 over the cosine. So this is really a graph that's an inverse of the cosine. So where the cosine is 1, like here at 0, you get a point in common with the cosine. But as the cosine goes down, this arm is going to go up. And as cosine approaches 0 at pi over 2, this function becomes undefined. And that's why they shoot up towards infinity and then down towards negative infinity down here. Then it comes back up towards negative 1, then off to infinity again as cosine again approaches 0. So you get these sort of humps on the top and the bottom here that are sort of an inverse reflection of the cosine. So that's what the secant looks like in general. Of course, you can do some playing around with the amplitude and phase shifted and all that stuff. So let's look at one of those. Here, what you can see is a lot more of these humps in a smaller area. So we know that we've added a multiplier to the x. And also, it comes down to 2 and up to negative 2. So we know we've changed our amplitude. This one is actually 2 times the secant of 3x plus pi over 4. We've actually shifted this thing in this direction, pi over 4. And you can see that because the point, 0 on the x and then whatever its amplitude is should be on this graph, but this one's been shifted pi over 4 in that direction. All right, let's look at the cosecant. So there's cosecant. Looks a lot like the secant, as you can imagine, except it's shifted in the way that the sine is shifted, because this is a graph of 1 over sine. So this is the cosecant of x. Now, at 0, the sine is 0, so this becomes 1 over 0 or undefined. So at 0, it's going to go up to infinity, down to negative infinity. Then, as the sine approaches 1, we get to 1 here. And then as it falls back down, it gets bigger and bigger on this side. And then undefined again, where sine is 0 at pi. So it's very similar to the secant function, just shifted over the way that sine is shifted over from the cosine function. So here we have y equals 3 times the secant of pi x over 5 plus 4 pi over 5. And we know, since we have this multiplier here, that the amplitude should be 3, and that doesn't actually help us. All of these come down to 3 and up to negative 3 on the, the vertexes of these little parabolas here. So that doesn't help us too much. We've also got a multiplier on the x of pi over 5 that's a little bit less than 1. So we know this function is going to be stretched out a little bit. And then we've got a phase shift, a fairly big phase shift of almost a whole pi there, 4/5 pi. So it's a little tough to tell which one is going to be the right graph here. And one of the things I like to do if I'm not sure is choose a value to plug in for x and test it and see which graphs it works on. The value that jumps out at me here is the value 1, x equals 1. Because if I put in a 1 here, I would have pi over 5 plus 4 pi over 5. That would turn this into pi. Now remember, the secant is 1 over the cosine. The cosine of pi is negative 1, so this is actually 1 over negative 1 times 3. So 1, negative 3 should be on our graph. And I have to be careful here because this graph is in radians. We have 2 pi out here. So 1 is going to fall somewhere short of this pi over 2 here. And where do I have 1, negative 3 on this graph? The only one it looks like is right here. So that's going to give us D as our correct answer. All right, let's look at one more. Here we have y equals 2 times the cosecant of pi over 4 times x. Now, pi over 4 times x, it's close to 1, so it's going to stretch this out a little bit. We've got a multiplier of 2 on the function, so our amplitude is going to be 2. All of them appear to have an amplitude of 2. So which one have we got here? Again, I'd suggest plugging in a value here. And, I might plug in 0 here since I've got no phase shift to deal with. So if I plugged in 0, I would have 0 here. And the cosecant is 1 over the sine. And the sine of 0 is undefined. So at the point x equals 0, this function is going to be undefined. So let's take a look for that. Definitely A is out. Definitely C is out. Looks like B and D are still in the running. The only question is, as it gets a little bit more positive, do I go negative value or do I go towards a positive value? So I might try the point 1 here for x. And then we'd have the cosecant of pi over 4. And let's see, the sine of pi over 4 I think is the square root of 2 over 2. So the cosecant would be 2 over the square root of 2. And we can fix the radical there. So we'd get, that would evaluate to just square root of 2. Then we'd multiply it by the 2. So we'd get 2 times the square root of 2. And that's, whoops, 2. And that's somewhere in the neighborhood of 3. But that's a positive value. So at the point 1, are we somewhere in the neighborhood of 3? And it looks like it on graph D down here. It does not look like, it looks like we're in the neighborhood of negative 3 there on B. So it looks like D is going to be our correct answer. So that's a little bit of work with the secant and cosecant graphs.